Okay, so I want to show you how the classical method works. Since we just went through the video of the slides, let's talk about how this works. So here we have our first one. To test the claim that H sub O equals 50 versus H sub 1 is less than 50, a random sample of size 24 is obtained from a population that is known to be normally distributed. My N is less than 30, so I have to know this to be true. Okay. If the sample mean is determined to be 47.1, compute the test statistic. Okay, remember our formula. Z is equal to X bar minus mu over sigma divided by the square root of N. Plugging in the numbers I know, that's 47.1 minus 50 divided by sigma's 12 divided by the square root of 24. And that, once I did my math, turned out to be negative 1.18. So I am 1.18 standard deviations below the mean. Okay. If the researcher decides to test the hypothesis that the alpha is 0.05 level of significance, determine the critical value. Now, I like to draw a picture, so I like to look at it this way. Here's my curve. I know it is left-tailed because it's pointing to the left. So that means I have to have a line over here, and then this space over here is my rejection region. That line is at negative 1.645. Now, how do I know that? Remember our little cheat sheet where alpha was 0.05, that is the value I'm going to use. That tells me that if I'm more than negative 1.645 standard deviations away, I'm going to throw it out. So critical value is negative 1.645. Again, you can look that up in your Z table. Look in the middle of the table for 0.05, and that will give you the 1.645. Okay, we are at negative 1.18, and if I grab my blue pen here and I mark negative 1.18, I'm about right there. Is it in the rejection region? So negative 1.18 is not in the rejection region. Therefore, what would we do? We will fail to reject the null hypothesis. Not so horrible. Let's do that again. Let's look at another example. Okay. Are women getting taller? A researcher claims that the average height of a woman ages 21 years or older is greater than the 1994 mean height of 63.7 inches. She obtains a simple random sample of 45 women and finds the sample mean height to be 63.9 inches. Assuming that the population standard deviation is 3.5 inches, test the researcher's claim using the classical approach at the alpha as 0.05 level of significance. Oh my goodness, we have lots of numbers here to pull out. So let's see. The height back then was 63.7. So that's the claim. Our claim is what? Researchers claim that women, she obtains a simple, claims the average height of a woman is greater than. So claim is the mean is greater than 63.7. And we know now that H sub O has to have equal in it, so mu equals 63.7. So H sub 1 must be mu greater than 63.7. Good start. All right. We know our standard deviation, I'm pulling numbers out, is 3.5. We know alpha is 0.05, and because it points to the right, this is right-tailed. Okay, again, right-tailed. Now, the value of alpha these are going to be pretty common. So when I have an alpha of 0.05 and it's right-tailed, it's the same as an alpha of 0.05 left-tailed, only it's on the right-hand side. So this is 1.645, just like it was in the last problem, but my rejection region is over here now. So this is the part I want to throw out. If it lands over there, it goes away. Anything to the left of it is okay. Anything to the right of it is bad. So if you want to look at it this way, anywhere over here is good. Over here is bad. Or this is do not reject. And this is reject. However you want to look at it. I'm just giving you a couple different options here. All right, looks like it's time to do some math. So we find our z. Z is equal to x bar. Ooh, that's 63.9. So 63.9 minus 63.7, bad 7, divided by the standard deviation, which is 3.5, over n. N was a sample of 45. So n is the square root of 45. I did my math, and I came up with 0.38. You can double check my math there. All right, remember, 0's in the middle. Here's 0. Here's 1.645. Where's 0.38? About right there. Is 0.38 in the rejection region or not? It is not, so we would fail to reject, which leads us to a conclusion. We failed to reject the null hypothesis. So what does that mean? Well, that means there is not sufficient evidence to support the claim that women are getting taller. Okay, so we've done a left-tailed test. We've done a right-tailed test. Let's see what number 3 is. Okay. SAT exam scores. A school administrator claims that students whose first language learned is not English score worse on the verbal portion of the SAT exam than students whose first language is English. Okay. So, what is my claim? Well, my claim is that the mean is less than what? It says worse, so we're going to do less. Okay, the mean SAT verbal score of students whose first language is English is 515. So what is my H sub O? And what is my H sub 1? Well, H sub 1, mu less than 515, mu equal to 515. Again, you can use greater than or equal. That's perfectly fine. I don't have a problem with that. Suppose a simple random sample of 20 students. Okay, and we have a verbal score of 458. So X bar is 458. N is 20. And we have a standard deviation of 112. I'm just pulling numbers out here. Ooh, alpha is 0.10 this time. So instead of, okay, so let's take a look. Here's my curve. So I go back to my little cheat sheet. If alpha is 0.10, then my number is negative 1.28. Again, I pulled that off of my little cheat sheet. So here's my rejection area. This is my non-rejection area. So I do my math. Z is equal to 458 minus 515 divided by 112 over the square root of 20. I got a math of negative 2.28. Negative 2.28. So what does that mean? Well, that means I'm negative 2.28 away from 0. Here's 0. So if this is negative 1.28, negative 2.28, it's got to be somewhere over here. So where am I? I am going to reject the null hypothesis. What does that mean then? Well, let's look back at our writing conclusions page. And that means that there is sufficient evidence to support the claim that, let's see, a little creative licensing here, that what? ESL students, English as a second language students, score lower on verbal. Okay, a little creative license there, but that's what it is. Okay, so now we've done 3 different tests. I know we've done 2 that we failed to reject and 1 that we rejected. So that gives you an idea of what's going on. We did not do a 2-tailed test yet, but that's no different, except remember I have to split and put my values on both sides. So other than that, I think we're in good shape.